Okay, hello. So I'm going to use my voice again now, but I won't use the webcam because I'm a bit lazy. Yeah, let's just finish this already because I don't have much time. I need to finish this as quickly as possible. So let's continue. So this is the part 2. So we were here, product pollution via fetch. So what this one was saying, what this was talking about, so we could control the second part of the fetch. So we could provide a method or a body. So yeah, we can control that part because this is an object, if you can see here. Yeah, I feel like if we get a object prototype, but to the method or the body method, yeah, we could possibly modify it, and every fetch will have that method and have that body. Okay, prototype pollution via fetch continued. This can lead to a number of issues. For example, the following code is potentially vulnerable to DOM access via prototype pollution. Okay, let's read it first. So we can fetch to my products.json where the method is get, then the response to I don't know what that is. Okay, that username, data username, section. Okay, so it will take the message data from X username. Okay, so this part is probably the part where it is vulnerable, right? The product list, product name. Yeah, what I feel like the problem is it was taking the data from X username. If we could get control of this X username, we could possibly inject some DOM access here. But yeah, let's read it first. To exploit this, an attacker could pollute the object prototype with a headers property containing a malicious X username header as follows. Yeah. So why do we need to modify the headers? Let me check again. Why is it on the headers part? Oh, okay, so fetch headers. Wait, let us just check in the console log. Let's just fetch and see what do we have. We don't have headers. What? Oh, no. I was wrong. Let's check out the photo first. Then constructor to type headers. It's undefined. So where is it? I'm a bit confused though. Where's this headers from? Okay, I'm gonna ask ChatGPT again. Doing prototype pollution. What we want prototype pollution. we are writing to prototype. Oh, don't say that this data is what you are giving the server is. This is the request that you are giving the server. Oh wait, does that mean that part of code is data from? Is it from? Is it? Let's just make it explain. So I'm a bit confused to so data is the response. Okay, so data is the response. Oh yeah, because the server fetches and we could modify the X username from the data. Oh, when data is accessing the X header, we could pollute the prototype object X header like that, so that it takes it from object inherits. Okay, so I think I understand this part. Okay, so we have to pollute the X username so that when they access the data, it will take the payload. But oh yeah, the data is passed to the it's stored into a username and it will be parsed here. Yeah, okay. Let's assume the server side. This header is used to get the value of X username property in return JSON file. In the formable client side code above, this is the assigned to the username variable, which is later passed into the inner HTML sync, resulting in DOM XSS. Okay, so let's continue. Object defined property. Wait, did I save it? Oh yeah, I saved it. Let's just continue that. Prototype solution via object-defined property. Developers with some knowledge of prototype solution may attempt to block potential gadgets using the object-defined property method. This enables you to set a non-configurable, non-writable property directly on the affected object as follows. object define property, formable object, gadget property, configurable, false, mutable, false. These may initially seem like a reasonable mitigation attempt, as this prevents the formable object from inheriting a malicious version of the gadget property via the prototype chain. However, this approach is inherently flawed. Just like the fetch method we looked at earlier, object-defined property accepts an option as objects. Oh yeah, for real. Known as a descriptor. You can see in this example above, among other things, developers can use this descriptor object to set an initial value for the property that's being defined. However, if the reason that they are defining this property is to protect against prototype pollution, they might not bother setting a value at all. In this case, an attacker may be able to bypass this defense by polluting object prototype with a malicious value property. If this is inherited by the descriptor object passed to the object-defined property, the attacker control value may be assigned to the gadget property after all. Yeah, kind of. Okay, let's save this part. Okay, let me put it here. Save it. Hello, Ang. What's up, Ang? Side prototype pollution. It is a potential gadget attempted to patch it. However, it can bypass the measures they have taken. Oh, does that mean it's the value of the transport URL? Maybe let's ask AI again. So the user didn't set a value on the find property. So if we pollute the proto value, we could set the value of call again transport URL. You say yes, no. Okay, so I think talking with ChatGPT 3 will lower my IQ, so I don't think I will continue talking with him. I know I understand it, because the value, it didn't set the value. Oh yeah, I forgot to test that. I forgot to test the object prototype one. The one where we do like this, then we can check the console for object prototype. Yeah. Why is the reset multi-pollution more difficult to detect? No source code access, lack of the developer tools, the DOS problem. Oh no, pollution persistence. Oh yeah, sounds very annoying. Detecting server-side prototype pollution via polluted property reflection. An easy trap for developers to fall is forgetting to or overlooking the fact that JavaScript for in-loop iterates over all of an object's enumerable properties, including ones that it has inherited via the prototype chain. This doesn't include built-in properties set by JavaScript native constructors, as these are non-enumerable by default. You can test this out for yourself as follows. What? Wait, let me save the ones from before. rare cases, the website may even use these properties to dynamically generate HTML, resulting in an injected property being rendered in your browser. Once you identify that server-side prototype pollution is possible, you can then look for potential gadgets to use for an exploit. Any features that involve updating user data are worth investigating, as these often involve merging the incoming data into an existing object that represents the user within the application. If you can add arbitrary properties to your own user, this can potentially lead to a number of vulnerabilities, including privilege escalation. This lab is built on Node.js, and the express framework is vulnerable to server-side prototype pollution because it unsafely merges user-controllable input into a server-side JavaScript object. This is simple to detect because any polluted properties inherited via the prototype chain are visible in the HTTP response. When testing for server-side prototype pollution, it is possible to break application functionality or even bring down the server completely. If this happens to your lab, you can manually restart the server using the button provided in the lab banner. Remember that you are unlikely to have this option when testing real websites, so you should always use caution, okay? So let's move to our super suspicious. Let's send this to the repeater. Can we do that multiple times? Let's see the response. Is admin false? Okay, interesting. What if we put a proto here with the data that is foo bar. So let's see. Okay, so we did that. What if we change the isAdmin to true? What happens? Ooh, interesting. Let's refresh and check the very cool. So how to solve? Delete the user Carlos. Okay, let's delete, and we have solved the challenge. That's very easy. Okay, so that was fun, very fun actually. So let's refresh and check the solution because we have solved it. Yes, identify gadget. Yes, I noticed the isAdmin property. Yeah, modify the isAdmin. Yeah, that was very easy. Super easy actually. Detecting server-side prototype pollution without polluted property reflection. Most of the time, even when you successfully pollute a server-side prototype object, you won't see the affected property reflected in a response. Given that you can't just inspect the object in a console either, This presents a challenge when trying to tell whether your injection worked. One approach is to try injecting properties that match potential configuration options for the server. You can then compare the server's behavior before and after the injection to see whether this configuration change appears to have taken the effect. If so, this is a strong indication that you have successfully found a server-side protopollution vulnerability. In this section, we will look at the following techniques: status override, status code override, JSON spaces override, char set override. What is that? All of these injections are non-destructive but still produce a consistent and distinctive change in the server behavior when successful. You can use any of this technique covered in this section to solve the accompanying lab. Okay. So let's save that. Wait a minute. Status code override. Server-side JavaScript framework like Express allow a developer to set custom HTTP response statuses. In the case of errors, a JavaScript server may issue a generic HTTP response but include an error object in JSON format in the body. This is one way of providing additional details about why an error occurred, which may not be obvious from the default HTTP status. Although it's somewhat misleading, it's very common to receive a 200 OK response only for the response body to contain an error object with a different status. Okay, that's really funny. The Nodes HTTP errors module contains the following function for generating this kind of response. The first highlighted line attempts to assign the status variable by reading the status or status code relative from the object, passing to the function. If the website's developers haven't explicitly set status property for the error, you can potentially use this to probe for prototype pollution as follows. Quoting the server status property, but be sure to use an obscure status code as unlikely issued for any reason. Trigger the error response again when check. Okay, so let me save that part actually. The one before. Am I lagging? For real? Okay, I'm back. Why is it lagging so bad? Just load, man, just load. Finally. Okay, let's continue again. Quickly, please. I want to solve this. It's taking so much time. It's not lagging. Maybe. Let me just open this in a new tab and see what happens. JSON spaces override. The Express framework provides a JSON spaces option which enables you to configure the number of spaces used to indent any JSON data in the response. In many cases, developers leave this property undefined as they are happy with the default value, making it susceptible to pollution via the prototype chain. If you got access to any kind of JSON response, you can try polluting the prototype with your own JSON spaces property. Then reissue the relevant request to see if the indentation in the JSON increases accordingly. You can perform the same steps to remove the indentation in order to confirm the vulnerability. Yeah, I was thinking about the same thing because you could just make the JSON doesn't have. We could just remove the tab spaces. So if it overrides the tab spaces, we know that we have a working prototype pollution. This is an especially useful technique because it doesn't rely on a specific property being reflected. It's also extremely safe as you're effectively able to turn the pollution on and off simply by resetting the property to the same value as the default value. Although the prototype pollution has been fixed in Express 4.17.4, websites that haven't upgraded may still be vulnerable. Taking so much time. I'm annoyed. Man, please just load. Please. Let's try opening on other websites. So let's try opening GitHub. Let's try opening the GitHub. This GitHub. Yeah, it's quick. I'm not lagging. What? Really, man? When I'm streaming? GG's. Okay, finally. Did someone pollute the server so it became down? Okay, I'm just joking. I respect you, but how obscurity? Okay, Express server often implement so-called middleware modules that enable pre-processing of requests before they are passed to the appropriate handler function. For example, the body parser module is commonly used to parse the body of incoming requests in order to generate a rack body object. This contains another gadget that you can use to probe for server-side prototype pollution. Notice that the following code passes an options object into the read function. Where is it? Oh, this is what he meant. Options object, yeah. So get char set, by parse char set to lowercase. What is a char set? Image. I want to see what char set is. Oh, is char set ASCII? ASCII a char set? Oh, okay, I understand now. So yeah, you will create a char set. You will get a char set rack for the request. Then after that, read request, response, next, parse, debug, and options object which is used to read in the request body for parsing one of these options. Encoding determines which character the encoding to use. This is either derived from the request itself via the getCharSetRack function call, or defaults to UTF-8. Oh. Does this mean we can maybe we could pollute the char set so we can check if the encoding is the same char set as ours, maybe. I'm not sure, I'm just guessing. Wait. Okay. Charge anymore? Wait. What's the battery? Yeah, it's 69. Nice. So if you look closely at the getCharSet function, it looks like the developers have anticipated that the content type header may not contain an explicit charset attribute. Yeah. Or 0 or nothing. So they have implemented some logic that refers to an empty string in this case. Crucially, this means it may be vulnerable, it may be controllable via prototype pollution. Yeah, if we can somehow get the control of the char set in the parameters prototype, yeah, we could get access. Okay. To pollute the prototype with the content type property that explicitly specifies the UTF-7 character set. Oh, so wait. Oh yeah, okay, so this is very smart. So let's say like this is like getting your profile, like checking your profile, and it will return our role, right? So this is the current role in UTF-8. But after we polluted the content type, the content type to charset 7, then it will change to UTF-7. So this will be red in UTF-7. That is this foo. Yeah, that's very smart. So let's save this. Actually, this is very, very smart. I want to save this so I can remember. Due to bug in Node's HTTP incoming module, this works even when the request's actual content type header includes its own charset attribute. To avoid overwriting properties when a request contains duplicate headers, the add header line function checks that property already exists with the same key before transferring properties into an incoming message object. If it does, the header being processed is effectively dropped due to the way this is implemented. This check, presumably unintentionally, includes properties inherited via the prototype chain. This means that if we pollute the prototype with our own content type property, the property representing the real content type header from the request is dropped at this point, along with the internet value derived from the header. What? I'm not sure about this part. Let me ask ChatGPT again. Does this mean the new content type is this rather than the original? Wait, I don't trust this ChatGPT again. So let's ask Gemini. Okay, so I trust Google Gemini more. Detecting server-side prototype pollution without polluted property reflection. So let's access this lab. This sounds very, very interesting. Much more interesting than the ones from before. Come on. Okay, nice. So let's copy this. Bring it here. Oh, it's still on full screen. Let's remove that from the repeater. And let's check. Let's log into our own account. Please, can you please enter? So it's basically the same. So let's put this to the repeater and see what happens. Okay, it's also so let's read the ones from before. Let's try triggering an error. So let's try triggering an error by what happens? Okay. It's now try to pollute the status code. Let's create a proto thought it works. What about the status? What if we don't? Then let's create the error again. Yeah, it works. Nice. Let's go. So let's try the other ways. What about the code lines? JSON data. What is it? Tab. Let's change the JSON spaces. What happens if we JSON spaces to 1 0? Doesn't work. I don't really understand the JSON spaces. But yeah, let's just continue that. I don't want to take lots of time solving a single challenge. So let's see the solution. Yeah, it uses the status also. Nice, let's continue. Scanning for server-side prototype pollution sources. Although it's useful to try manually probing for sources in order to solidify your understanding of the vulnerability, this can be repetitive and time-consuming in practice. For this reason, we have created the server-side server-side prototype pollution scanner extension for Burp Suite, which enables you to automate. Oh no, which enables you to automate this process. But the basic. Okay, server-side prototype pollution scanner. Is this free? Is the app in website free community? yes. Respect. About Pro, so I'm not reading that. Websites often attempt to prevent patch prototype pollution vulnerabilities by filtering suspicious keys like crypto. This concentration approach is not a robust long-term solution, as there are a number of ways it can potentially be bypassed. For example, an attacker can obfuscate the prohibited keywords so they are missed during the sanitation. For more information, see the bypassing flawed key sanitization. Access the prototype via the constructor properly instead of the proto. For more information, see the prototype portion. Constructor. We can access it by constructor, and the flawed key is the one that's similar to the file upload one. Node applications can also delete or disable proto altogether using the command line flags. Respectively, however, this can be also bypassed by using the constructor technique. So the constructor prototype, right? Very interesting. Bypassing flawed input filters for server-side prototype pollution. So, okay, fine. Hopefully I can solve this. Admin is true. What happens? Nothing. What about using prototype? No. Constructor. I'm not even sure. Oh, it works. Okay. Nice. Start. Delete the user values. So I don't know how to enumerate this one, so let's view the solution first. Oh yeah, I forgot about this JSON spaces. But how do you know that it's vulnerable to JSON spaces too? property which is currently set to false. Yeah. It's basically the same to what I did. Let's refresh to see the solve. Let's continue again. Remote code execution via server-side protopollution. Yeah, let's just keep reading this part. Okay. From request, there are a number of potential command execution sinks in Node, many of which occur in the child process module. These are often invoked by a request that occurs asynchronously to the server with which you're able to pollute the prototype in the first place. As a result, the best way to identify this request is by polluting the prototype with a payload that triggers an interaction with bird collaborator when called. The node options environment variable enables you to define a string of command line arguments that should be used by default whenever you start a new node process, as this is also a property on the environment object. You can potentially control this via protopollution events if it is undefined. I don't think I understand this part. So let's just continue first. Some of Node's functions for creating new child processes accept an additional shell property, which enables developers to set a specific shell, such as bash, in which to run commands by combining this with a malicious node options property. You can pollute the prototype in a way that causes an interaction with bird collaborator whenever a new node process is created. Oh no, I don't have bird collaborator. This way, you can easily identify when a request creates a new child process with the command line arguments that are controllable via protopollution. Yeah, this is the problem. I don't have burp collaborators, so I don't think I can solve any challenges in this part. Methods such as child process spawn and child process for enables the developer to create new node subprocesses. The fork method accepts an options object in which one of the potential options is the exact argv property. This is an array of strings containing command line arguments that should be used when spawning the child process. If it's left undefined by the developers, this potentially also means it can be controlled via the protopollution. As this gadget lets you directly control the command line arguments, this gives you access to attack vectors that will be possible using node options. Of particular interest is the // default argument, which enables you to pass in arbitrary JavaScript that will be executed by the child process. This can be quite powerful, enabling you to load additional modules into the environment. In addition to fork, the child process module contains the exact-sync method, which executes an arbitrary string as a system command. By changing this JavaScript and the command injection sinks, you can potentially escalate prototype pollution to gain full RCE capability on the server. Okay. Check if the result is run or not. process exec sync. Can take the we have exec sync that does a. So what is the goal of the challenge? Let's remove this. Why is it wrong? All required process dot exec sync. It's the same, right? Oh, it's different. So what's let's continue. That was very bad. Remote code execution via chat processes exec sync. now we are on the preventing prototype pollution vulnerabilities. So oh yeah, I forgot to. Okay, so you guys can't even hear while I'm speaking. Okay, noted. We recommend patching any prototype pollution vulnerabilities you identify in your websites, regardless of whether these are coupled with exploitable gadgets. Even if you're confident that you haven't missed any, there's no guarantee that future updates to your own code or libraries you won't introduce new gadgets, paving the way for viable exploits. In this section, we'll provide some high-level advice on some of the measures you can take to protect your own websites from the threats we have covered in our labs. We will also cover some common pitfalls to avoid. Okay. Sanitizing property keys. Okay, so we can sanitize the proto. Okay, we can use a block list. Okay, so let's save this. Preventing changes to prototype objects. Okay, this is interesting. So we can stop the changes in the object. Okay, let's continue. Preventing an object from inheriting properties. Well, can use object freeze. Okay. Oh. Okay, I didn't know about that. So we can set the object. Although a map can still inherit measure properties, they have a built-in get method only returns properties that are directly defined on the map itself. Oh, okay, I understand now. Yeah. So